In our previous video, we did some planning on the static routes and how we were going to add them to our little 3-router topology so that we could have end-to-end connectivity. Well, with that plan in mind, it's now time to implement those static routes on our topology. As a reminder, here is the plan that we came up with as far as adding 2 static routes on R1, adding 2 static routes on R2, and adding 2 static routes on R3. If you want to take a screen cap or jot these numbers down separately, that way as we go through the lab, you'll remember what those addresses are. I'll walk you through the syntax and how to verify that the static routes took, and I would love it for you to replicate it in the labs as well. And oftentimes people will watch the video once all the way through, and then they'll come back and watch it again, step through it step by step, while they follow along with me doing the hands-on. Either way is great. Let's begin. Alrighty, we're going to start off on DCNUG, and we'll just pop in the password there and log in. In the upper left-hand corner, we have the network topology, which I find very handy to just click on it, bring it up. That way I can look at it if I need to. And then also we have the multi-tab PuTTY in the upper left-hand corner, and let's launch that as well. So here in PuTTY, if the servers tab is not showing, you just click on servers right here, and then go ahead and launch your devices. So we'll run a console to R1, go back to servers, go to R2, go back to servers, go to R3, and then we can close that tab and have R1, R2, and R3. And for a clean slate, we just press enter a few times. If you ever log out accidentally and need to log back in the lab environment here, you can log in as Bob and there's no password. It'll bring you right back in. All right, so starting on R1, based on our plan, let's do a couple things. This is really important. Before we start configuring, we want to verify the current state of the device, in this case, this router. So one way of doing that would be to show IP interface brief. And that way we can verify the interfaces are up, they have the correct IP addresses, and we can also spot check our work. So if we bring up the topology here, we have 00 and 10 with .1 on each, the 10.1 network on the left and the 10.12 network on the right. That looks great. Okay, super. So as far as the routes that we're going to add, let's bring up that work as well. And that is right here. We're going to add 2 static routes for 10.23.0 and 192.168.1.0. And they'll both point to the next hop of 10.12.0.2, which is R2. And because the syntax may be brand new to you, let me walk you through it. So what we're going to do is on R1, we'll go to configuration mode. And in configuration mode, from global config, that's where we add these static routes. So to do that, in fact, let's do a do show IP route. You can add the do command without having to go all the way back to privilege mode. And that way, if you're in configuration mode, you need to issue a command real quick. You can just throw a do in front of it. And if the syntax is right, it'll take it. But I just want to take a look at the routing table. So we have the directly connected networks, and that's it at the moment. So from global config, we're going to use the command IP space route, and then we'll do a question mark. And the option that we're going to choose is this, the destination prefix. That's a fancy way of saying, what network do you want to add the static route for? And the first one that we talked about, if I bring that back up, the first one is the 10.23 network. So let's add that one first. So we'll type in 10.23.0.0, and then we're going to put in the mask. I'll use a question mark to help reinforce that. 255.255.255.0. That way we're adding a static route for a 24-bit network, the 10.23.0 network. And then if we use question mark again, we have too many options. There are just so many options here. But the option that we're going to use is the next hop's address, which is in dotted decimal format. So in our topology, that next hop device would be R2 and R2's 00 interface, which is 10.12.0.2. So that'll be the next hop that we're going to add. So I'm going to hit Q to stop the scrolling, and I'm going to put in that next hop of 10.12.0.2. And then there are some additional options after. We'll save those for another discussion, and I'm just going to press enter. Then I'm going to use the up arrow key a couple times and use the command do show IP route, because I'm still in config mode, and press enter. And check this out. This is what we just added to the routing table, a static route. So here at the beginning it has S, and the code for S represents a static route. And it's to get to the 10.23.0 network with the 24-bit mask. Our next hop, we're going to go via 10.12.0.2. That's the next hop in the path. So that is one route we've entered. We need to do one more. So let's go ahead and look at our plan. And the second one is going to be the 192.168.1 network with the same next hop. So we'll go back to the router interface. I'm going to hit the up arrow key a couple of times. And this is going to use the back arrow and replace this network with 192.168.1.0. because it's the same next hop, and press enter. And then if we do a show IP route, now we have 2 static routes right here. So that is fabulous. Let's go on to router 2. So if we go to router 2 and we go into configuration mode, let's take a quick peek at our plan so we can implement the correct static routes. So back at our plan for R2, we're adding a static route for 10.1.0 via R1, which is 10.12.0.1, and a static route to 192.168.1.0 via R3, which is at 10.23.0.3. Okay, I think I've got it. Let's go ahead and configure. So here on R2, we're in global configuration mode. We'll do IP route space, and our first network is 10.1.0.0 with a 24-bit mask. And the next hop is going to be R1's interface of 10.12.0.1. And when I say R1's interface, I'm referring to the IP address that's on that next hop interface on R1. And we'll press enter. Awesome. 1 down, 1 to go. Our second one was IP route for the 192.168.1 network with a 24-bit mask. And the next hop for that was R3. And let me just peek at R3's address real quick. So R3's address is going to be 10.23.0.3. Fantastic. So we'll put that in, and then we'll get out of configuration mode, and we'll do a show IP route. And there's our 2 static routes. So we've got this one for the 10.1 network via R1's address as the next hop, and this one for the 192.168.1 network with R3's IP address as the next hop. All right, 2 routers down, 1 to go. Let's go over to R3. So over here on R3, we'll click on that tab. We'll go into configuration mode, and we had 2 networks we need to add, the 10.1.0 and the 10.12.0. And anytime as we go through this, if you want to peek at the topology, I've got it right here. So that file is sitting on the desktop of DC Nug if you want to look at it. Or if you want to go back to our plan, we can go ahead and look back at this anytime we need to. Or if you've written it down like I did here, you can go back and look at those notes as well. So on R3, our 2 routes are for 10.12 and 10.1, both using R2 as a next hop. So here in R3, we'll add the first route, IP route. The first route is going to be 10.1.0.0 with a 24-bit mask. And the next hop is going to be R2's address of 10.23.0.2. And then for the second route, we're going to go ahead and do 10.12.0.0 with a 24-bit mask. And the next hop is the same, 10.23.0.2. Fantastic. And then we'll exit out of configuration mode, and we'll do a show IP route. And that looks great. Now, I want to share with you a tip that it took me a long time. I got my first CCIE back in 2001, and I don't know what it was, but it took me a long time to really appreciate during that process about how to test the network without relying on end devices. Because if we tried to, from R3, ping this PC, maybe it has a firewall on it, or maybe it doesn't have a default gateway. If we just want to verify the network itself, what we could do is we could do a ping from R3, but we could ping R1. And so that way we can verify the network. But one question might be, well, that doesn't verify that we have reachability to the 10.1 network. Because if we ping R1, we're pinging 10.12. So the answer to that is you can ping the far interface. So from R3, we could ping 10.1.0.1. It's still not testing the whole network, though, because the response, when R3 pings R1, the ping is going to go to whatever IP address we specify, but the source is going to be the closest one in the routing table to that destination. So R3 is going to source the packet from the 1023 network. So that doesn't guarantee that R1 can actually get back to the 192.168.1 network. So to cut to the quick, the way to really test this is with an extended ping. And we can use a couple special commands, and we can tell R3, hey, ping, but instead of just sourcing it from any interface you choose, source your ping from here, and let's go ahead and ping this address. And that way we can test the full range of the network. And we don't have to involve clients on the ends that may or may not have configured default gateways correctly, or they may have firewalls that may obstruct our progress. So having said that, let's go ahead and let's do several tests just to demonstrate. So let's go to this PC in the lab environment. That's the Windows 10 client. And let's verify whether or not this PC can ping all the way over here to .200. If that works, that verifies we have full connectivity between those two networks. So if that works, that's great. And then I'll also show you how to do the pings from the router's perspectives. So back in the lab environment, I'm going to the client PC. and I'm going to log in to the client PC. This is on the 10.1 network, 10.1.0.10. We can verify that real quick just by going to a command prompt, and from a command prompt typing ipconfig. There we go. So 10.1.0.10, and it currently has a correct default gateway. That's good news. So if we do a ping out to 192.168.1.200, which is a device on the far right-hand side of the topology, and that works. Yay! That's fantastic. Now, if that didn't work, the next thing that we could do is go to a router and test from the router's perspective and not try to go all the way to an end client. So in the interest of seeing that, let's go back to DCNUG. And here on DCNUG, we're sitting at router 3. And let's do a ping space. And if we do a question mark, you notice we have some options here. So if we specify IP, and that would be versus IPv6, then we could do a ping to 10.1.0.1, which is the IP address of R1's 00 interface, and we do a space. Check this out. We can also specify a source. And this is where we can say, I want to source this with another question mark. I want to source this from my IP address of 192.168.1.3. And I've got a wacky address there. So I need 1, and there we go. Much better. And then we have our complete path. So regarding routing in our little 3-router topology, we've had a nice 1-2 punch. And the first aspect of that was the planning steps as far as what static routes do we need, logically, what would they be? And then the second one in this video, we had some hands-on practice in implementing those static routes and also verifying that they worked. We also took a look at an option or two that we could use to test end-to-end connectivity without relying on pesky hosts or devices that sometimes might give us grief as we're testing that connectivity. So I would encourage you in this video to watch it all the way through at least once if you haven't already, and then schedule time to do the hands-on practice to replicate what we did together. And the cool thing is, if you want to do it again and again, you can. Just log back into CVT Nuggets, relaunch the lab, and get that hands-on practice. So thanks for joining me in this hands-on lab regarding network-based static routes, and we'll take a look at host-based static routes in the very next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.